Welcome. Today's final high school exam exercise is on trigonometry. It's on the highest level of high school, so have a look. It's equivalent in your country to this level. Have fun with it.
Well, let's have a look at what kind of exercise we have today. And here it is. Let us first attentively read the assignment description. About the circle with center 0, 0 and radius 1, a point A moves with motion equations x of t equals the sine of t, y of t equals the cosine of t. This on the interval between 0 and 2p only. About the circle with center 0, 0 and radius 2, a point B moves with motion equations x of t equals twice the sine of 2t, and y of t is 2 times the cosine of 2t, again on the interval 0 between 2 pi. In the figures 1 and 2, the two circles and the line segment AB are drawn for the time instance where t is 0 and t is 2. At the time instance where B is located on the x-axis, A is located on the line with the equation y is x or on the line with the equation y equals minus x. And the exercise is to provide proof for this statement. First, let's get some feeling for this exercise. We can see that the motion equation for point A is given by the sine of t for the x of t and the cosine of t for the y of t coordinate. So we are used to have the cosine related to the x-coordinate and the sine related to the y-coordinate. In this case it's the other way around, but that actually doesn't matter much. The only thing that it does is that when t is 0, the point starts rotating here and then in a counterclockwise direction. So for point B, we can see that the x of t is twice the sine of t. That means that there's also a circle still, but it's not a unit circle, it has a radius of 2. Not only that, it also moves at double speed, what you can see right here. So every time that point A, for instance, covered an area of half pi, which is this, then point B would have covered half a circle. Okay, I think we're ready to address this question. Let me first clean this up. Okay, so now we need to think. When B is located on the x-axis, that would mean that the y-coordinate of B would be 0. So let's write that down. The y-coordinate of B equals 2 times the cosine of 2t, and that must be 0. So working this out is pretty straightforward. We get these 4 time instants. Never forget to add k times 2 pi to one of these answers to underline the periodicity of these kinds of equations. However, in our case, it was given that the interval for both points is only between 0 and 2 pi. Therefore, k times 2p, we can leave it out. Now we're going to have a look for each of these 4 time instants. What are the y and the x coordinates, and do they indeed obey the equations y is x or y equals minus x? So here are the 4 time instants, and let's start with 1/4 of pi. The xa of 1/4 of pi equals the sine 1/4 of pi equals 1/2 square root of 2. And for the y-coordinate, we get also half times the square root of 2. So in this case, y equals x. We repeat this for every time instant. Here you can see for 3/4 of pi, and the y-coordinate 3/4 of pi equals minus half square root of 2. So in this case, y equals minus x. For time instant 5/4 of pi, we get this, and we get this. Both are minus half square root of 2, and then y equals x again. And finally, t equals 7/4 of pi. We fill it out, in the motion equation, and we get that y equals minus x. So all these four time instants are either on y equals x or on y equals minus x. And thereby this statement that we needed to prove has now been proven. Now let's have a look at the second part of this question. In figure 3, the line segment AB is depicted at a time when it's horizontal and located above the x-axis. There are two instances when the line segment AB is horizontal and below the x-axis. Exercise 2. Calculate the coordinates of point A rounded to one decimal place for one of these instances and draw the corresponding line segment AB in the figure. Okay, so what happens when A and B are on the same horizontal line? That would mean that their y coordinate is the same. So let's first revisit the motion equations for each point. And then here we have the expression ya of t equals yb of t, thereby guaranteeing that we're discussing a horizontal line. Filling this out, we get that 2 cosine of 2t equals the cosine of t. So this exam was kind enough to already give us a couple of equations. One of them is written here. They were just written on the exam paper and we get them for free. So let's use them. Cosine 2t equals 2 cosine squared of t minus 1. If we substitute that in the formula here, we get 2 times and then between brackets 2 cosine squared of t minus 1 equals cosine of t. We're going to rewrite this a little bit and then we get this quadratic formula. 4 cosine squared of t minus cosine t minus 2 equals 0. Now if you see this kind of quadratic form, you should actually always immediately remember the ABC formula, which is written right here. We are going to apply this and then substituting cosine t for x in this equation, this one right here, with a equals 4, b equals minus 1, and c equals minus 2. Leads us to cosine of t equals 1 plus or minus the square root of 33 divided by 8. So this has two solutions, either 1 plus square root of 33 divided by 8 and the other one is 1 minus square root of 33 divided by 8. So the first one leads us to cosine t is roughly 0.843 or the cosine of t is roughly minus 0.593. Now we need to remember that the cosine of t is the same as the y coordinate of point A. And according to the exercise, the line segment, so both coordinates of A and B, needed to be below the x-axis. Therefore, immediately the positive answer can be ignored, should be ignored. Therefore, we continue with cosine of t is minus 0.593. Typing this in your calculator, be sure to have it on radians. T equals the inverse cosine of minus 0.593, or the arc cosine, which is the same, leads us to t is roughly 2.206 plus k times 2p. But again, because we're looking at the interval from 0 to 2p only, you should say t is equals 2.206. And there is another solution, t equals minus 2.206. But we're lazy, and because the exercise says for only one of these instances, therefore we continue with plus 2.206 only. So with that, the coordinates of A for the t is roughly 2.206 is 0.8, comma, minus 0.6. And for the coordinates of B, we get minus 1.9, comma, minus 0.6. And let's just for fun also calculate the other one for minus 2.206. There you can see it. Now the final part of this question is to draw the corresponding line segment AB in the figure. Here we're going to draw these points. Here you have the A coordinate 0.8, comma, minus 0.6. And here we have the coordinate of B, which is minus 1.9, comma, minus 0.6. And the corresponding line segment looks like this. So for this other point where t equals minus 2.206, I will give you the answers right here. Thing would be the same if you have a figure again. Here's point A, and there's point B, and there's your line.
Now that was fun. Okay, thanks for watching. Please leave a like, subscribe, and hope to see you in the next one.